themselves out of bed to come to school for one reason: learning, hopefully. Especially from the perspective of students and teachers in a program like the IB that strives, even in our mission statement, to cultivate lifelong learners, how we learn is always a pertinent question. There is a body of knowledge surrounding this, including my real-life situation for today, the book Make It Stick, The Science of Successful Learning, only recently published by Harvard University Press. So the main arguments of this book is that retrieval information, or recalling a concept from memory without looking at material, is better than the repetition of ideas, which is rereading or highlighting. So naturally, what we're concerned with is how cognitive scientists gather such evidence to come to this conclusion. So my knowledge issue for today is, what role does the methodology of the human sciences play in substantiating claims over the effectiveness of different learning strategies? There are different research methods used in the human sciences, such as introspection, case studies, surveys. Our scientist, Roediger, conducted an experiment. So he asked American students to learn 70 Swahili word pairs, English word pairs, and after a week he asked them to recall the English word from the Swahili word in a quantitative test. So there were 4 groups of students. 2 groups practiced retrieval learning once, and 2 groups practiced retrieval learning several times. And the dark blue bars represent students that were allowed to reread the words as many times as they like. As you can see, there's virtually no improvement when they were allowed to reread the words as many times as they liked. So Roediger came to the conclusion that retrieval learning is indeed better than repeated study. So we have to look at the methodology that they adopted in this experiment. So firstly, the hypothesis and observation was inextricably interlinked. Over many years, Roediger made a number of observations through his sensory perception. He could see that his subjects reacted to different methods of learning, which led him to develop his hypothesis that retrieval practice is indeed better than repetition. However, what scientists like Roediger perceive in their observations is subject to quite a few limitations, which I will briefly outline. For example, confirmation bias. From the perspective of Roediger, he would be looking for data that supports retrieval learning. The motivation for observing will color his observations. This is closely linked to the problem of demarcation. Roediger is limited by his tendency to draw a line and limit his experiment such that only data that supports his thesis is considered. Also, there's the problem that Roediger is human. That's a paradox of the human sciences. It's that humans are studying humans. In the study of ourselves, it's hard to detach some sort of emotion or cultural perspective that is typically eschewed in human sciences because when they seek to emulate the objectivity of the natural sciences, which I will explore later. So that is not to say that these observations are valid, but it does highlight the importance of measurements and experiments to support them. So there's an attempt at systemization in the human sciences that provides some sort of consistency or objectivity, which leads us on to the measurement or experiment. So the experiments that Roediger conducted were controlled. There were 70 Swahili word pairs. There were groups of college students of similar caliber, and they were measured by a final standardized test of their ability to match words. And there was a repeated study of over 100 students. However, there are some methodological flaws that cannot be overlooked. The issue is with the parameters critical to the experiment. So firstly, controllability. The human sciences have many variables to control, and often these cannot be controlled and can be difficult to identify. For example, there are other factors that affect the effectiveness of learning, like genetics, the current intellect of the students, whether they attempted to study the words within that week. And also, the test is a representative measure of long-term memory retention. After all, they were tested only after 1 week, which is hardly long-term. And the test is arguably simplified in this case, but the complexity of studying human behavior often renders simplification imperative to understanding. So, repeatability. Scientists like Roediger cannot repeat the same test with the same student using different modes of learning. So there's this compromise between controllability and repeatability. From the perspective of natural scientists like Ernest Rutherford, arguably experiments in the human sciences cannot be repeated. He says the only possible conclusion the social sciences can draw is some do, some don't. Although there is some truth in this, I believe that conclusions are still relevant. So the question is really bridging the gap between experimental conclusion and practical application. So in this, we can look at reasoning. So Rödinger's results are then applied to the general population through inductive reasoning. Because it's effective for Rödinger's X-test studies, it means it extends to the rest of the population. But of course, this can be a problem in making generalizations based on their aggregate. So these are American students. How about the different students around the world? And also, we have to emphasize the difference between laws and trends. There are limitations to controllability, measurability, and repeatability, as I mentioned before, inherent in the human sciences. So that makes the formulating of laws difficult. So, which suggests that the evidence may be inadequate. So this is induction with a proviso that's about trends. So if we look back at the graph that Rödinger provided us, it's very telling that even he acknowledges and emphasizes that it's about trends in the cognitive sciences, because he's very cautious in affirming a definite causal link, as can be established in the natural sciences. So there are gaps in the method in theory, but I like to believe that it does not completely compromise scientific application. Inevitably, there will be variation and anomalies, but conclusions can be drawn within a certain margin of error. So that's another knowledge issue we could explore, which is the role of mathematical reasoning in aiding the generating of knowledge claims in the human sciences. But I can't go into that today because of time constraints. And so, looking at this issue from a wider perspective, there have been many different experiments that produce results proving that retention practice is indeed better. In this way, there's some form of independent testimony. These results were obtained separate from each other, and the coherence of these results overcomes some limitations, like the problem of confirmation bias. I also found it very interesting that praise for the book was evidence-based. This exhibits our paradigm, the scientific paradigm, and we put a lot of trust in what science presents to us. Therefore, it's of paramount importance that we keep in mind some of the limitations of the human sciences. Similar to one of the best comic artists, Gary Larson, I personally believe that retrieval learning is more effective. It works better intuitively for me. And I think we have this emotional tendency to believe in it. We're more ready to believe in these conclusions because we would like to believe that we do better as learners. We find connections in knowledge and not in mechanical repetition, and that we hit the limit of what we can retain. Our brain is full, and we're not robots. So this has further implications of learning, especially to educators. Learning is usually thought to occur during episodes of studying, whereas retrieval of information on testing simply serves to assess what we have learned. So putting it into a larger context, we have to change the way we look at learning and the role of testing, which affects how we connect ideas in our understanding of the world. So everyone has a perspective on education. When it comes to education, we all call ourselves experts. But it doesn't take an expert to tell you that there are large differences in learning styles and different cultural perspectives on what is best. There are grounds to believe that certain methods of learning tend to work better in a particular environment or culture. So, for example, the difference between individualist and collectivist perspectives on education. The individualist perspective is adopted in more Asian societies where students are encouraged to work independently, and the collectivist perspective is encouraged in Western societies where students engage in discussion and arguments to learn to think critically, which is what the IB adopts, kind of. And so, as an Asian student in studying the IB curriculum, there are large differences in learning styles, even and views on education, even compared to my parents. So, obviously there will be no homogeneous agreement on what is effective or how to achieve it, but cultural differences do lend themselves to different conclusions. So, in conclusion, the process of human sciences provides evidence to support our knowledge claims. There are limitations to this, but some of these limitations can be overcome by doing different experiments. And uncertainties and anomalies are unavoidable, but the conclusions are critical, especially since we are so concerned with ourselves as humans. So, experiments, case studies, and so on in the human sciences are undeniably useful in supporting our knowledge claims. Thank you.
Thank you.